So today we're going to be solving the week 11, we're in week 11? Yeah, week 11 chemistry AMS quiz. Let's start. So which of the following represents the complete combustion of C2H6? So C2H6 is an alkane. When you combust it, you're adding O2 to it. So C2H6 plus O2. And whenever you have combustion, you're going to have the products H2O and CO2. So now all this question is asking us or testing us on is our ability to balance. So to balance this, you have to look at the options we have. You need two C2H6, 7 O2. Now you have 4 C's, so this has to be 4 CO2. And then you have 14 O's. So here you have to write 6 H2O because you already have 8 from here, 6 left. It's literally practically all balancing. If you want, just memorize. Reactants in an esterification. When you want to make an ester, which is practically the COO, this is an ester bond. When you want to do this, you have to do an organic acid with an alcohol, because the alcohol is gonna give you the O, and the organic acid, never mind. And the organic acid is gonna give you the CO. So you need the organic acid and the alcohol. Now moving on. How are alkenes produced? Alkenes can be produced in one of two ways: by cracking alkanes or by dehydration of alcohols. These are the only two ways they can be produced. Okay, so which of the following is the formula of alkanes? Memorize this. It came in our AMS 2 weeks ago because nobody did the AMS last week. This is the alkanes, and for the one having 2 carbons, it's C2 and H2N, which is 2 plus 2. So you're gonna have C2H, 2 times 2 is 4, plus 2 is 6. Moving on. Anyways, for this question, they're asking, which of the following is the general formula for alkenes? Alkenes, they have the formula of CnH2n. So if an alkene has 2 carbons, you're gonna have C2 and H2 times 2 plus, that's it, not plus, that's for alkanes, sorry. So it's C2H4, and that's it. Moving on. Okay, this all memorizing, but okay. So a polymer is a substance made of macromolecules, and it's formed when molecules called monomers join. So polymers are made out of monomers. Polymerization is when you link small and simple molecules, which are monomers, and they form polymers. Polymerization occurs when molecules bond by either breaking a double bond, like if you had C like this, you'd break this bond and do this, or by eliminating small molecules. Memorize this. It's definitions. Move on. The process of linking really small and simple molecules to form large macromolecule units is called polymerization. So the process of making polymers is polymerization. Moving on. Now, which of the following? Okay, so natural polymers. 2 examples of natural polymers would be starch and proteins. Because they're found in nature, you cannot make them, or you can, but you can't actually produce them naturally. Synthetically, in a lab. Synthetic polymers, usually they have the weird names, or the names like polyvinyl chloride, or polyestyrene, or polyethylene. These are all synthetic. This question, you don't even have to know the lesson to know the answer, but disadvantages: contributing to a rapid depletion, and that they are usually not biodegradable. Whereas advantages is they're easy and inexpensive, and they can be customized. You can make whatever you want in a lab with polymers. Okay, so an alcohol has what effect on wet litmus paper? We know the only thing that affects litmus paper is either an acid or a base. Whereas an alcohol is none of the above. So it will have no effect on wet litmus. Moving on. Okay, so here you have a fractionating column, and they're asking you separating petroleum into fractions. Now, what's the most volatile fraction? So listen, let me quickly do a quick brief explanation on how this works. So you're gonna have the oil coming out from the ground, and then they're gonna do with their boiling points. They're gonna boil them on low temperature. The least dense part, or the most volatile part, is gonna go up to the top and leave from fraction A. So the least volatile has to be at A. And then they keep increasing the boiling point until you go up, for example, and it leaves from B, goes up, leaves from here, then leaves from C, then leaves. The most dense one isn't gonna evaporate, so it's just gonna leave from D. Now let's see. So you're testing here their boiling points in a fractionating column. Most volatile is gonna be the highest one, A. Here you're rearranging fractions in decreasing order of boiling points. So the one with the most boiling point first, then to the least. Most boiling point is gonna be the one near the bottom, then this one's in the middle. A has the least boiling point. Now for this part, I'm gonna go to the notes for it, and I'm gonna go scroll up to the fractionating column that they gave us somewhere. Where though? Okay. For this, I have a way you can memorize the which one is first and which one is last. It's a little sentence, like to memorize them. So it goes like this, but let me find it really quickly. Okay. So it's Ralph got no ketchup dipping for lunch break. It's gonna sound like very weird, but it's a way to memorize. So Ralph refinery gas, which by the way they also call this petroleum gas, got for gasoline, no nafata, ketchup for kerosene, dipping for diesel, for fuel, lunch for lubricating oil, and break for bitumen. This is how you memorize them. Now let's go back to our quiz. Fraction A, which in here is our top one, is gonna be petroleum gas, which is the same as refinery gas. Fraction B, let's go back up to the diagram. Sorry guys, I was shifting. Fraction B is the next fraction, which we said is Ralph got, so it's gasoline, which is the second one. C is here near the bottom. In the options you're gonna see. So in the option, the only option that's before bitumen in the options is lubricating oil. So you're gonna do that because it's right before bitumen, and then D is always bitumen. There's another question with more options, by the way. Okay, this question I got it wrong for the dumbest reason, because I spelled it wrong. I wrote a P capital instead of lowercase p, which I don't know why that matters, but looks like it does. You know what? I'm gonna go back to my answers. So yeah. Name the type of polymerization that the ethene undergoes. Whenever we have an ethene, it's always addition. Now, give the name of the polymer Teflon. You're gonna say, okay, where do we get this from? It's polytetrafluoroethene. You can get it all the way from this table that we have to amazingly memorize. Produce your own way to memorize it. Do what you please, but it has to be memorized. And this part also, the uses. So we memorize the use cases and we memorize their names or their chemical compounds. By the way, polytetrafluoroethene is the same as Teflon or Tefal or PTFE. So yeah. So this is the polytetrafluoroethene. Now, if n molecules of tetrafluoroethene are polymerized, locate the repeating unit. So look, it's ethene, so you have to have two C's. And it's polytetrafluoro. So tetrafluoro. You have to have, tetra means 4. So fluoro is F, so 4 F's. And since it's an ethene, but we broke it with addition, you're gonna have 2 broken bonds, and to make it a repeating unit, you break the bond and add n. This is how you draw a repeating unit. So I'm gonna repeat. This was like, tetrafluoroethene is like this. To make it a repeating unit, you'll remove one of the bonds, you're breaking the double bond, becomes a single bond, and you're adding 2 bonds to the side. You're adding your 2 brackets and the n. This is a repeating unit. Now, moving on. Okay, here we can actually use it. A, Ralph, which is petroleum gas. Got is gasoline, but here we said, as you could see in the picture, it's gasoline or petroleum. You could choose whatever name you want. So petrol or gasoline, they're the same thing. So got, no, they never ask us about nephron or nephron, I forgot what it's called. Yeah, no ketchup, kerosene. 4, wait, no ketchup dipping, so diesel is next. 4 is whatever it was, and lunch break, lubricating oils. Now, so okay, yeah, so it's nafata for n, no, and it's fuel oil for 4, but they didn't put them here. It's supposed to be this, then petrol or gasoline, then nafada, kerosene, diesel oil, fuel oil, then lubricating, then bitumen. So yeah. Moving on. Okay, so listen. Whenever you see this O, it means oxidization. Don't even think about it. Don't think twice, don't think once. It's oxidation. Moving on. The general molecular formula for a carboxylic acid is this. It's always CnH2n plus 1. Why plus 1? Because you're going to have an H here. Then COOH. This is your functional unit. Moving on. Okay, so ethanoic acid is produced by the oxidation of ethanol. Only. If you oxidize ethanol, you get ethanoic acid. Of course, you need some catalysts or some things to go with it, but we'll talk about those in another question. Moving on. Now, the general correct molecule formula for alkanes is, we already said this, it's CnH2n plus 2. I don't know why they're repeating this. And for alkenes, CnH2n. Okay, so whenever you see red-brown color of bromine decolorized, it's by an ethene or any third of alkene, because alkenes undergo bromination. So whenever you have C2H4 plus Br2, you're gonna substitute. So let's draw it. H. You're gonna substitute Br. So you're gonna substitute, let's say, BrCH2 and... Guys, my bad, I don't know, my video cut, so I'm like back to this point. So we have the ethene molecule. Now what's gonna happen is we're gonna cut the bond, become 1, and now we're gonna add 2 Brs to the side. You could add, instead of 2 Brs to the side, you could keep an H here and move a Br here. or maybe H here and Br here. Depends on what you want. So that's what they did here. They did CH2, then Br, then CH2, then Br. Which means they put them on the sides. But it doesn't matter. You can have them anywhere. They're all going to be named bromoethene. It's called actually 1,2-dibromoethane. If I'm right, yeah. Anyways, but they didn't ask us to draw it. Just know you're gonna have two bromines. Now C2H6 plus Br2 is gonna produce no reaction because bromination happens with alkenes, not alkanes. Moving on. Okay, this is the substitution reaction that gets speeded up by UV light, and it substitutes chlorine in place of hydrogen. Now, which of the following is a reaction between methane and chlorine? Now, when you have a methane and a chlorine, so I'm gonna draw it. Methane plus Cl. So what's gonna happen is we're gonna link these two together and substitute these two. So then you're gonna be left with HCl, and in this case, CHCl. So this is two products we could have, which are these two, this one and they didn't really put it here, but this is also a possible product. You could have, let's say, 2 Cls, you could have 3 Cls, or you could have 4 Cls, Cl4. All work. This is also another answer. So all of these are your possible answers, but I only explained this because some people were asking how HCl, where's the C? It's because you're substituting, so these two are gonna go and form their own bond. That's why. Moving on. So which of the following is the type of reaction? We have an ethene, and so it's obviously gonna be a addition reaction if it's with an ethene. When you add hydrogen, or more specifically it's called hydrogenation, when you're adding a hydrogen to an ethene, what are you gonna form? C2H6, because it becomes, you're adding H2 to CH4. C2H4, when you add H2 to it, it becomes C2H6, which is an alkane, which means it's saturated, because alkenes, anything with no double bond is saturated. If you have a double bond in it, it's unsaturated. Now choose the reagent that converts ethene to ethanol. It is steam. Moving on. Here, you have to have Cl2, because we are, what's it called? We are replacing the ethene with Cl2, like we did in the previous question. So we're gonna have the Cl sitting at the edges. You're not gonna have a Cl sitting on a main branch. They always have to be to the edges. Moving on. Unsaturated. When you see the word unsaturated, means double bonds are present. Of course, again, alcohols. CnH2n plus 1 OH. And an alkanol, or alcohol, is gonna have an OH in it. Only one OH. Not O, not O, not OH and O. Only an OH, one OH. Okay, so which of the following produces sucrose into alcohol? It's fermentation. Biological catalyst is yeast. By the way, this is another one of the ones where if you put capital Y, it will give you wrong for some weird reason. So beware. Now, which of the following products described in the reaction? If you took bio, you would know it's ethanol and carbon dioxide. This is memorization. Now, how do you extract concentrated alcohol? By fractional distillation. That's literally the only way. Now, moving on. Okay, so like I told you, whenever you see this O, it's oxidation. Now the chemical formula for product X is, because we're making out of ethanol, we're gonna make what's it called? Carboxylic acid. So you're gonna take you're gonna get rid of an H2O, and then it'll have the formula of CH3COOH. Memorize this. Now, whenever you're gonna have potassium manganate, it's purple to colorless. Potassium dichromate, orange to green. These are all memorization for this question. Moving on. Okay, for this question, they're asking us about the structural isomers. Now, structural isomers mean they have the same shape with branches. So this, we do line test. If one line can pass through all the C molecules, then it's not a structural isomer. It's an isomer, but not a structural one. If you want a structural isomer, if you draw a straight line, it cannot pass through all the C's. Let's try this straight line. Still not passing through these C's. This straight line, not passing through this one. There's not one single line that you can draw and go back without going back on. So this is a structural isomer. This, you could either go like this, like this, like this, like this, like this, but not one line where you can get all of them. So this is also a structural isomer. Moving on. Last question. Okay. You have a propanoic acid and an ethanol. When you have a carboxylic acid and an alcohol, it's esterification. And the reverse of esterification is hydrolysis. And product A is gonna be your alcohol, then your acid. So it's ethyl propanoate. Ethyl propanoate. Now, product A. Okay, so look. You need to be careful. Which one is your propanoic acid and which one is your ethanol? It's gonna have one of these two formulas, okay? Because you have to have the double COO bond. Now, by the way, this also has to bond to an O. Any ester in the world has to have this bonding. If you do not see COO, it's not an ester. Now you're gonna see, okay, what's the difference between this and this? Here, you have two C's on your acid. We have propanoic acid and ethanol. If I'm not wrong, wait, let me go back and check. Propanoic acid and ethanol. So we need to be sure that the one that has 3 carbons is our acid, not our alcohol. The alcohol is this one. Why? Because it's the one with OH. But you're gonna say, okay, where's the H? We are gonna eliminate the H. Here we also have COO. OH here also. We have a missing OH from here. But whatever you see the double bond, it's gonna be in your acid. So your acid is the one that's propanoate, so it has to have 3 C's. And ethanol is 2 C's. So just be careful. This is propanoate. Or no, propanol. Sorry, my bad. This is propanol. And this is ethanoate, sorry, yeah. Now, whenever you have, so we have prop, which is 3, and ethanol, which is 2. Prop means propanoate is 3, ethanol is 2. So you have a total of 5 carbon atoms. Sorry. So if you want to make a thing that has the same molecular formula, you have to have the same number of carbons. This has 1, this has 3, so total of 4. This has but is 4, F is 2, so this is a total of 6. Ethanoic acid has 2, propanol is 3. You're gonna see, isn't that the same thing as up? No, up we had propanoic acid and ethanol. Here we have ethanoic acid and propanol, so it's producing 5. C is our correct answer, but let's look at D. 2 and 1 is 3. So the only correct one is C. And that's the end of our quiz. Hope you understood everything. Have a nice day. Bye.